Thank you very much for coming along today. This is the first in the UK NCSP webinar series. I'll say just to begin with that we are going to record this webinar and it will be put on YouTube later. So if that makes you uncomfortable in any way, then please beat a hasty retreat at this point. Other things to say, we will be taking questions and answers. The Q&A function on Teams is open, so please put your questions there. We'll have a Q&A session at the end where we'll go through as many of those as we can and give you the best answers we possibly can. Anything we don't have time for, we can take offline and get back to you offline. The chat function is also open, so if you've got any technical problems, anything you need help with in terms of hearing properly or anything like that, then you can make comments there and our wonderful tech people will hopefully resolve those for you. The seminar today is about UK Climate Projections 18. We'll hear more about that in just a moment. We've got some really good speakers lined up to tell you all about that and how it's going to progress, what happens beyond, and so on. Before we get to that, I thought I would just take a couple of minutes of your time and tell you a little about the UK National Climate Science Partnership, UK NCSP, because I'm aware that it's a relatively new activity and not all of you will have come across it before. UK NCSP is a new national initiative that seeks to leverage the climate science capability of a bunch of UK research institutes, many of which are NERC supported, and also the Met Office. They're listed here so you can see which ones we're referring to. The idea behind UK NCSP is that these labs actually support a great deal of the large-scale, long-term climate science capability in the UK. And by that, I'm thinking about things like sustained observational networks, or the construction and running of large-scale climate models, or hosting of key infrastructure. These labs often work together already on various different projects, but it's not always the case that they have joined up capability, joined up activities on the same sort of scales that you would need for optimal climate science to inform evidence. And at the end of the day, it's creating that climate science evidence and passing it to the stakeholders, the policymakers who can action it, that we need to do. So UK NCSP has been created. The idea is to leverage this capability better between these institutes and then also connect it outwards to the rest of the community. So it can actually try and generate community-wide activity across the UK and even internationally to enhance the climate science that's conducted and the decisions that are made upon that climate science. So if I can have the next slide, please. We would like your engagement on this. We've drafted a strategy for UK NCSP, which is now up for consultation. So we've written down the things that we think are important and how they can be taken forward. And it's all built around trying to leverage the capability better with outcomes that we're seeking to enhance. And then look where the gaps and weaknesses are in the flow of evidence from that capability through activities and actions and the generation of that climate science and the use of that climate science. And then seeking partnerships and seeking to fill any gaps and weaknesses where we think we can make better climate science and have climate science used better within the UK and beyond. Can I have the next slide, please? So as I say, we've drafted this strategy. It's now up for consultation. There's a QR code here. So if you're able to scan that, that will take you to the strategy. There's also a little URL there. If you don't have time to scribble these down, don't worry, we'll show them again at the end. There is a pro forma also where we've actually scripted some questions that we really would like answers to. There's also a lot of blank space where you can tell us anything that you feel would be most important. And it's really about what do you think are the biggest opportunities? How would you like to engage? Who are the key partners that we should be connecting with? How can we better translate the knowledge for the stakeholders? And so on. And so please do give us feedback, please to engage on this and moving forwards. On the diagram here, there's some of the coordinated actions that we've already started spinning up, and they relate to various things such as sea level rise, CMIP7, and so on. And the one that I've circled here is about delivering the next set of UK climate information, which neatly is the subject of today's webinar. So I think that's all I need to say at this point. And what I will do is hand you over to Professor Jason Holt. Lowe, sorry, wrong Jason. I always get that wrong. From the Met Office, who will tell you about UKCP18 and beyond.
Thanks, Mike. So what we want to talk about today is the future of UK climate projections. We're at a point where we need to ask, both from a user perspective and from a science perspective, is there a benefit from moving beyond where we've got to in UKCP18? We want to do this differently than we have in the past. We want to include a greater range of voices. Today is part of that, and we'll build throughout this webinar through a number of speakers towards a call for evidence. And we really hope you're able to spend a little bit of time telling us what you think about the needs for UK climate information. Next slide, please. I wanted to start with a reminder of what UKCP18 is. On the right-hand side is what we call the wheel of UKCP18, and it lists the different products that we have and the different tools that we have. So if we start at around the 11 o'clock, you can see we have probabilistic projections. These are widely used to provide context for the amount of future change for different emission scenarios as we progress through the 21st century. We also have sets of future realizations from climate models, and we have global projections which help us understand what's happening on the large scale and also beyond the UK. And they're a mix of variants of the Met Office model, but also bringing in other models from the CMIP exercise to give a wider sampling of uncertainty. We do downscale some of those models, so we downscale to around 12 kilometers over Europe, and the really exciting bit in UKCP local is that we downscale to 2.2 kilometers over the UK. So that's taking weather forecast models that previously had been focused on a few days of running, and instead we're running them for climate length experiments out to decades into the future. And that helps us better simulate and better understand changes in extremes and sub-daily information. We also have observations that are aligned to the form of the data used in the projection, so they can be used much more seamlessly. And we have marine projections that initially focused on sea level rise and water levels at the coast through changes in storm surge and waves. Overall, when we look at these, the headline message is a greater chance of warmer, wetter winters and hotter, drier summers. And it's framed as a greater chance of, because we will still get cold and dry winters and cooler and wetter summers. So we need to plan and have information to help inform a greater envelope of future conditions. Now, are people using this? We have a website that we produced at launch. We also have a user interface to focus on getting the data. That's a point and click type interface. And there are also many users can download the raw data for those who want to work with NetCDF files from the CEDAR archive. And if we think of the numbers of users, well, using the user interface, there's now around 13,000 users registered. And from the feedback we're able to collect, we can see they come from a range of sectors. So in particular, there are large numbers from the flooding and water management sectors, but also large numbers from energy and those interested in biodiversity and nature. And increasingly, more people who are identifying as multi-sector, which is encouraging because of the idea of cascading risks. If we could have the next slide, please. So when we think about a applying UKCP18, I wanted to come up with a couple of examples. So on the left-hand side, the Met Office Climate Data Portal is another way at getting at UKCP and other data sets that are relevant to climate. We have around 20,000 users now registered. We launched it last year in June. And the reason this is important, it enables people in a GIS environment to overlay the climate projections with information and data that's relevant to their use case. So we've seen users overlay extreme temperatures with care home settings or adverse weather days onto the rail network. And we're seeing people build applications within that platform. We also have a group that has helped us throughout recent years, the Development and Knowledge Sharing Network. And they've helped us understand where we need to get better at either providing additional products or guidance around products, including what we can and can't do with the data that's available, because there are limitations. That's actually led into an open webinar series where sometimes we have technical discussions on good practice, for instance, around topics like bias correction. Other times we hear from people who've actually used the data, what they've done with it and what has enabled that to happen and the barriers. So you can see those on YouTube. And on the right-hand side, I wanted to show some particular applications. So UKCP18 has been heavily used in the National Adaptation Plan and CCRA work so far. The top diagrams are showing results from a project led by Mike Sanderson, looking at wind-driven rain and producing a data set for that. The bottom case, this was around producing storylines for helping to think about the resilience of national infrastructure. And that included colleagues such as Lizzie Fuller and Jenny Perrett. Next slide, please. We're now in the CCRA 4 cycle, and I suspect quite a few people who are in the audience are involved with that, because we have a consortium that brings together the Met Office academic partners, and importantly, members of the UK National Climate Science Partnership. And UKCP provides extra tools that we can draw on throughout CCRA 4. On the left-hand side, Chris Short is reporting on extra UKCP local simulations that broaden the uncertainties that we're able to sample. In the middle case, John Tinker has produced data for the shelf seas, for instance, providing temperature, salinity, column stability, etc. And there are 12 ensemble members that can be accessed, for instance, through CEDA. And then on the right-hand side, we have a number of pieces of work that are helping to map the UKCP data onto global warming levels, which is a framing we're seeing increasingly used and is good for some applications. Hamish Steptoe has recently published a paper with James Murphy on this that's very interesting to read. We also have work from Peter Good, who has been looking at the UKCP local data on global warming levels and comparing it with other ensembles. And we'll be putting out more data specifically for users. Next slide, please. So today is really thinking about looking beyond this period of producing upgrades that use the UKCP18 approach into whether we need to provide a bigger update. And we don't know the answer to this yet. This is an answer that will evolve through discussion, for instance, with government and other users. And we want to make sure there are voices in here from the wider user community, but also from the academic community and other providers. So what's actually changed that might motivate an update? So the users of climate information have changed. There are certainly more of them, but what they need, what they're asking for, has evolved. We have many users who are now incredibly experienced at using climate data in their own applications. But we also have new users for the first time thinking they'd like to factor in climate change to the work they're doing. Fi will be telling us more about that in the next segment. So the providers of climate information have evolved a lot over the past 5, 6, 7 years. So as an example, there are many academic projects that are producing decision-relevant climate information for the UK. We'll hear from one of those later. Len Shaffrey will be talking about the work in Canary. But across UK academic research, there's a whole host of approaches and data sets that are now relevant to planning our future in a changed climate. There's also the private sector. The private sector increasingly are providing approaches, tools, services to help build resilience and to help the UK adapt or move to a low carbon future. And the research councils increasingly are focusing on climate solutions. Also, the climate science has changed, and to me, this is really exciting. We can have my final slide, please. So because the climate science has evolved, we can think of what building blocks might be available when we think of, is there a need for an upgrade? Because actually, there are many more opportunities. And if we look at the climate science focused on the left-hand side of this diagram, the first two lines are very relevant to thinking about the present and near present day. We have tools such as event attribution or large present day ensembles, including the unseen method. We have advances in teasing out skill from decadal forecast. We need to ask the question whether they could really help the community that needs climate information in the UK. If we look at the blue sections, this is in the space of several decades ahead and builds on what we've had in UKCP18. But there are many new techniques. Just last week, there was a workshop at University of Bristol with colleagues from the Met Office as well on the regional environmental prediction model. So looking at the idea of coupled local simulations. But there's also progress in high resolution global modeling on using techniques to weight and constrain model ensembles so they perhaps give a better representation of what the real world might do. And there's also new work around storylines and high impact, low likelihood events that we could draw on if we did want to produce an update. There's new work on impacts. So for instance, the OpenClim consortium and community produced a framework to couple together impact models over the UK and produced a lot of example data. And elements of that are now being transferred to the Daphne platform for wider use. There's new understanding around systemic risks and cascades of risks, for instance, work at the University of Newcastle and elsewhere. And we're learning from other disciplines like catastrophe modelling. And that brings me on to my final point, the red column here. We need to now look beyond the physical sciences and draw on a really wide range of disciplines. And when I think of just a few where the advances can feed into potential new information for decision making, well, there's decision science, decision theory. There are new co-development approaches. There are new comms approaches. There is evidence around how we think about this in an ethical way. And there's an emerging and developing literature around climate services to deliver operationally some of the advances that we see in the science. So I'm going to hand over at this point to Fi to hear about the user learning we now have.
Great, thank you, Jason. So if I can get going to the next slide, please. Thank you. So I'm going to be talking about the results of a user consultation strategy that started at the beginning of 2023, and it's part of the DEFRA-funded UKCP climate service that I lead at the Met Office. And the purpose of the user consultation strategy was to help the Met Office and the wider UK climate provider community to understand the usability and the usefulness of UKCP18, but also to kind of explore the needs for future UK climate information from the perspective of users. So as part of that consultation, you can see at the top of the slide there that there are kind of multiple components of it, with an online survey that was launched in January 2023. And then we followed that up with 4 focus groups that followed the survey where we had a number of people from the Met Office academic partnership universities who helped facilitate deeper dialogues with various users on different sectors, essentially, to trying to draw out a bit more than what we got from the survey. And as Jason has already mentioned, we do have this monthly webinar series that started last June, where we are getting a few more insights into how people have used it and some of the challenges that they face when using climate data, but also, what they're actually applying the data for. So onto the online survey, we had 380 people who have responded to the survey. We're still collecting survey responses as we go along, but so far we have about 380. And as you see, the kind of people who have actually responded come from multiple sectors, with some sectors less represented or well represented than others. But one of the interesting things is that if you have a look at the orange slice here, where we have quite a large portion of the survey respondents are from scientific and technical advisory services. Just as Jason said, it's an area, or the private sector, which is a large area which is growing. And I guess many users are actually relying on those services to provide information based on UKCP18. And if you see the pie chart at the bottom there, the scientific and technical advisory services really represent a large range of other sectors that are probably not as well represented in the survey. So we're hoping that we're capturing a lot of I guess a fair representation of users across the UK. Now, the survey included multiple choice questions, but also free text responses as well. So I thought it'd be useful to provide some examples of that. Obviously, there's a huge amount of data here. So what I'm trying to do here today is just provide a kind of overview summary, which might help us a little bit with the conversations that we'll have later. So here we have some examples of responses which included the topic around uncertainty. And so here there's some examples around communication about actually the kind of information that people want around uncertainty, but also trying to understand a bit more about I guess navigating the information from storylines to global warming levels that Jason has already mentioned is becoming quite a popular way of looking at climate projections. So on to the next slide. Here is a kind of overview of two aspects of the survey that we've got so far. And the left-hand side, where we show the data use, what are people actually using the data for? So this question, respondents were allowed to tick multiple boxes. And as you see, there's 268 respondents, so not everyone had to respond to this question, but the majority did. And what we find is that people are using the UKCP18 data, and primarily the top three are looking at risk assessment and also impact models and studies there, with others and actually further down, which is more around kind of directly taking tangible adaptation decisions. But obviously some are doing that, which is great to see. We also asked around emerging needs. We had several questions which tried to explore that and trying to understand not only what the challenges they face, but kind of what kind of information would they also like in addition to what they see currently with UKCP18. And so these are kind of the top level, high level ones that we have seen from the survey. So this includes additional emission scenarios. So at the moment, the UKCP18 has multiple emission scenarios in the data set, but for the climate model, direct climate model output, particularly UKCP local and regional, we only really had the time to produce for the high emission scenario, the RCP 8.5. And we're also getting requests for more information on global warming levels and multiple global warming levels. The second box on the to the right of that is around the derived variables for sectoral impacts, which really is talking about kind of variables that can be used in impact models, but also derived from impact models. So for example, flooding and drought or some sort of heat stress. The other bits that I just want to highlight here are around high-end scenarios, which are really becoming something that's definitely you hear more often, and also information beyond 2100, because many of the assets have a lifetime of about 100 years, and at the moment many of the kind of detailed projections only go to 2100. And I think one of the new areas which we probably haven't seen much before is around that last box around the decadal forecasts, where people are finding out about decadal forecasts. But I guess a lot of the suggestions tend to be focused on the rather than talking about decadal forecasts. I guess the way they express it is through kind of planning for the next year to the next 20 to 30 years. So I think, yeah, so that's quite a newish area that we haven't seen very much before. So I'm going to hand over next to the next speaker, Carol. Over to you, Carol.
Thanks, Vi. So I want to, I'll introduce myself. I'm Carol McSweeney. I'm the Deputy Science Lead at the Met Office for UKCP. So I want to talk a little bit about the next steps. And so particularly I want to say something about how we'd like the wider community to have a role in the future evolution of UKCP. So I've listed a few examples of projects that were previously funded through the recent UKCR Climate Resilience Programme. And I think these projects demonstrate a model for working together to capture a wider range of perspectives and expertise in the space of UKCP that we'd really like to build on. So what does this model look like in practice? Well, if we think of where we're at now, we are currently working with DEFRA to assess the need for a major update. So you can play a role in this stage by contributing to the call for evidence that we're launching today. If the outcome of that assessment is that an update is required, then we would move into an options appraisal and delivery phase. We're still working on what those phases might look like, but some of the ways that we're thinking of involving the wider community could be via a community sandpit event to bring ideas to the table. We'd also like to bring a wider set of views into evaluating those options and work towards a model where partners are part of the delivery and governance teams. I perhaps should say something now also about the timeframes. So currently we're in this first stage and there's a decision point this autumn. And if that update is agreed, then an options appraisal will follow and take us into the early part of 2025. But in terms of delivery, the timeframe is yet to be decided, but we do envisage that a major update would be delivered on a timeframe of a number of years. So coming back to the current stage where we're assessing whether there is a need for that major update to UKCP18, bearing in mind the significant cost to users of updating their risk assessments, we've considered quite carefully with DEFRA what might be a trigger for a major update. And we've defined these as either science triggers, so that's perhaps where there have been changes in the scientific understanding that could potentially have a material impact on decisions made with the data. Or those science triggers could be where there have been developments in scientific methods, such that a known unmet user need could be addressed. There are also user triggers. So that's where a user need may have evolved to a point where there's a significant new requirement that can't be addressed with the current data, that could be addressed with an upgraded package. And this is where you can play an important role. So we'd like you to help us to understand whether there are triggers for a major update, and we're launching this call for evidence. So you can reach that through this QR code, but if you don't catch it now, I will we'll show it again at the end, and I'll also follow up with an email with all the details for the call for evidence. So we'd like to hear from you as experts in the fields of climate science, climate predictions, climate projections. We'd like to hear from those of you who are experts in applications of climate information, perhaps to climate impacts, or in adaptation and resilience settings across the UK. And we'd like to hear from people in a wide range of types of organisations. So we'd like to hear from the research community, as well as practitioners, those in the public sector and government roles, and in the private sector. So we've heard a little bit from Fi about what we've been doing in the user space to help us understand whether we've reached user triggers. But we want to spend some time during the rest of this webinar to start thinking about what some of the science triggers might be. And in a moment, I'm going to hand over to our speakers, to James Murphy, Segalen Berthu, Len Shaffrey and Gillian Kay, who are going to talk us through 4 examples of where science has moved on since UKCP18 in ways that could have material impact on decisions or demonstrate how new capability could meet user needs. So these are just 4 examples. We think that there are potentially other triggers out there, and we'd like to hear about those from you via the call for evidence. So at this point, I will hand over to James initially, who will make a start.
So I'm James Murphy. I lead the land component of the UKCP projections. And this is just one slide to give you a heads up on our current thinking about a potential science trigger for an update of those. And I guess in this wider UK climate information space, we could now start to think of the sort of main UKCP projections as maybe a kind of workhorse set that is designed to sample an even range of outcomes and be used in multiple applications potentially. So here I'm showing a kind of standard picture which illustrates all the components that Jason mentioned of the current set of projections, and these are looking at national changes for summer and winter precip and temperature for Scotland and England. And so the coloured dots show the global, regional and local projections that all consist of sets of raw climate model output, and therefore usable to derive a range of kind of potentially complex impacts indicators. And then on the left is an uncertainty synthesis in the form of the probabilistic projections shown by the boxes and whiskers. And I think the key point I want to make was that when we launched UKCP18, it was certainly the richest data set we'd ever produced in terms of its range of content. But partly because of the different stages that different modeling tools were at the time we launched them, there were certain disjoints in the products because they were derived from different modeling components. So in particular, if we look on the top left, we see what I think is now a widely understood, somewhat narrow range of high warming that comes out of the latest parameter ensemble of our CMIP6 model that we ran for UKCP18. So in the global runs, those are the orange dots on the top left there. And then we use those to drive regional models, which are the pink dots, and then the UKCP local runs, which are the green dots. And because of that sampling limitation, that the product was entirely based on Met Office modeling at that point, you can see that we're only really sampling the upper half of a wider space that's revealed by either the CMIP5 models in the blue or the probabilistic projections in the boxes and whiskers. And similarly, another kind of the exciting developments, as Jason mentioned in UKCP18, was the advent of the UKCP local runs for the first time, including a representation of explicitly convective scale dynamics. And if we look on the bottom right, that revealed some kind of new emerging results to us. So if we look at just mean winter rainfall changes or precip changes on the bottom right, we can see that compared with the regional models, which didn't include the convective scale dynamics, there was an uplift in the envelope of potential changes. And we think, at least in part, that did arise from the advection of maritime showers over land that isn't present in any of the other products. And because, for example, currently the probabilistic projections, while they include downscaling, are not based on the UKCP local runs, they don't include that mechanism. So that might be missing the possibility of some upper end winter precip changes. So the thinking in the cartoon at the bottom is to propose a sort of cleaner design in which we derive all the components of a potential updated set of projections from the same collections of updated and improved modeling. Now in the grey dots on the left, we've shown the CMIP6 ensemble. And as you can see there, that gives a very diverse set of changes for all these variables. And it also gives improved modeling compared to CMIP5. So that gives us the potential to base the design more around that, but also including emerging modeling capability from potentially the CMIP7 Met Office model. And in particular, there's potential to include some simulations using higher resolution eddy-rich oceans, which might also reveal the possibility of new kind of high-end changes in some aspects of UK climate as well. So the thought would be to derive a new ensemble of that with improved regional and local models, and then use all that data to generate all the components in a coherent fashion, including an update to the probabilistic results, as well as regional, local, and global. So with that, I'll stop and I'll hand over to Segalen.
Hello, so yes, I'm presenting the Regional Environmental Prediction project that Jason and James have mentioned before. So this is a coupled model that brings together the atmosphere at 2.2 kilometers, so correct, similar to UKCP local, but we've enlarged the domain, and it brings it together with the land surface, but also with the waves and the ocean, and they're coupled together with the OASIS coupler. And we're also currently bringing in the environmental components, which are chemistry and aerosol in the atmosphere and biogeochemistry in the ocean. And the aim for this is to understand regional coupled feedbacks better. So I'll give an example of a marine heat wave study that we've done with it, but also to better predict multi-hazard compound events at the coast, for example, when you've got high river flows, surge, waves happening together during storms. There's also the idea to bring together the marine projections and the local projections in a more consistent way with that system. And obviously also to link the research communities together. And you can see that this is a collaborative project with UKCH, National Oceanography Centre, British Geological Survey and PMLs. And we had a workshop earlier this week, which was very successfully bringing together lots of people and brainstorming lots of ideas on how to use that system. Next slide, please. So this is just to compare what UKCP18 was running in terms of local projections. So the lighter blue shows you the atmosphere and land component. So UKCP18 local had a 2.2 kilometer resolution, which explicitly represents showers and thunderstorms. But the sea surface temperature it was receiving was from a global 25 kilometer model that doesn't see the tidal processes over the shelf areas. And the new set of marine projections that have been released by John Tinker are a 7 kilometer model that is in the middle, and that was driven by the global UKCP18, so 60 kilometer model. And that regional ocean has explicit tides and terrain following coordinates that enable shelf processes to be much better resolved. And what we're doing with this regional couple system, while we're running currently, is reproduce these UKCP18, but coupling together this 2.2 kilometer atmosphere, adding the rivers to it thanks to CEH, and also coupling that with the ocean, the waves at kilometer scale, and the coupling frequency is 10 minutes. So we've got really high frequency of coupling between these components. Next slide, please. So this is just an example of how we've used the couple system to understand marine heat waves. So last June, it was a very unprecedented marine heat wave, which reached 5 degrees anomalies around the North Sea. And you can see it's a widespread category 1. So each category, so category 1 is not even marked on the figure because it was all of the whole domain was under category 1, and then you reach category 2, 3, 4. And these categories represent how much above natural variability these temperatures were. So very widespread category 2 and 3 marine heat wave. And then on the right here, it's what happened last May. So last May was very sunny over the ocean, but not over land. And it's brought, again, these marine heat wave states. So it was category 1 and category 2 over different areas of the shelf, but you can see the North Atlantic was not impacted as much. But we've shown with this scupper system, please next slide. No. Next slide, please. Yep. So we've shown with the scupper system by running some counterfactual experiments with and without the marine heat wave that these high sea surface temperatures were affecting obviously air temperatures over the UK, and you can see on the left that they've warmed the UK by about 0.6 degrees. And it was the first time that the UK broke its temperature record by 0.9 degrees. Usually the record temperatures are broken by 0.1, 0.2 degrees, but this time it was 0.9. And we think it's because of the compounding nature of the sea surface temperature rising so much and the land temperature under these conditions. And you can see on the right, last May, we also broke the record temperature by 1 degree. And people were very surprised because it was not a very sunny May, and it was due to nighttime temperatures being quite large. And we've shown that the marine heat wave had a similar impact to June, so 0.55 degrees on the UK temperatures. So again, it was a compound event between marine and land temperatures. So it's these kind of compound events that we can study with the couple system. And I'll stop here. Pass to Len.
Hi everybody, I'm Len Shaffrey from the National Centre for Atmospheric Science, and I'm going to speak to you a little bit today about using large ensembles to inform decision making. So by large ensembles, I mean running a climate model many times, so typically sort of 30, 40, 50 times, in order to explore the internal variability that the climate model generates. And doing that allows us to address two decision relevant questions. The first of which is how large is climate change compared to internal variability? So we know the variability around the mid-latitudes and around the UK is large. So the position of the North Atlantic jet stream and the variations in the circulation in the North Atlantic Ocean can have a huge impact on the weather and climate that we experience in the UK. So if we want to understand the signal of climate change, then we need to think about doing that in the context of large atmospheric and oceanic variability, whether that's thinking about historical trends and how they've changed, or thinking about future projections. So a really nice example of that was published last year by Robert Vittard and others, thinking about the observed trends in extreme summer temperatures seen over Europe. So in that paper, they looked at this in some detail, and in particular, they noted, and it's been noted before, that when you look at the extreme warming that's seen over Europe, in models, you find that that warming is underestimated compared to the observations. And they explained that to some extent in this paper by looking at the impacts of the atmospheric circulation on extreme surface temperatures over Europe. In particular, what they find is a dynamical trend, so a trend associated with more frequent southerly flow over Western Europe, which explains about a third of the observed trend. So if we want to understand how things are changing in the climate system, then we need to explain and understand both atmospheric and oceanic variability. It's an important component of trying to inform decision making. Next slide, please. So in the Canary project, we're also running a large ensemble to address these questions. In particular, we're thinking around how will climate change affect weather extremes. So Canary is a large national capability multi-center project that involves 7 NERC research centers and the Met Office as a project partner. In Canary, we're producing a large ensemble by running the CMIP6 HydroGem3 model multiple times. So we're running that at resolutions of 60 kilometers in the atmosphere and a quarter of a degree in the ocean. And running that 40 times from 1950 to 2100. So that will produce roughly about 6,000 years of model simulation that we can look at the internal variability of the atmospheres in the ocean and what impact that has on weather extremes over the UK. If you're interested in looking at that data, because roughly about 50% of it has been produced already and is stored at Jasmine, then contact Reinhard Schiemann in NCAS at the email address you can see in the bottom right. So the other partners in Canary will be looking at a whole range of different extremes. So for example, doing hydrological modeling to think about winter flooding, summer flooding, and things like droughts. We're also looking at heat waves and extreme winds and stream storms in the Canary simulations. So Segolem was just talking about the need for high resolution data to think about the dynamics and the structures of storms and kind of the atmospheric circulation at these kind of small scales in order to look at weather extremes. So in Canary, we're also producing a range of output to support regional modelling in Canary and other projects. Next slide, please. So what we'll be doing in Canary is taking the most extreme storms that we're seeing in our large ensemble and then downscaling them to 12 kilometers and down to 2.2 kilometers using the HADGEM3 regional model. So these are atmospheric only simulations opposed to the coupled simulations that Segolem was talking about, but they'll allow us to look at the atmospheric dynamics that are going on in these extreme storms. When I'm talking about intense storms, what I mean is the most extreme windy storms and the most heavily precipitating storms that we see in the UK in the Canary Large Ensemble, and we'll simulate, or we are simulating, a set of storms for the present day conditions and future conditions, so we can see how the dynamics of those storms are changing under climate change. And just to give you a flavour of some of the results that we're producing, on the right you can see the surface winds from the most intense windstorm from about 2,500 years of Canary Large Ensemble data. And you can see it from the climate model on the left and then downscale to 12 kilometres on the right. Soon we'll have simulations down to 2.2 kilometres. And you can see as we increase the resolution, we're able to capture some of the mesoscale circulations in that storm that leads to strong and damaging winds. So this sort of information can be used to inform decisions in applications such as insurance and finance, but also thinking about engineering and infrastructure. And also it can be used to think about other approaches as well. So for example, informing hill scenarios or storyline approaches. And I'll stop there.
Hi, I'm Gillian Kay, and I'm going to tell you a bit about Unseen, which is unprecedented simulated extremes using ensembles. We know that climate extremes can have large impacts, but given the limited sample of extremes that we have recorded, how well do we really understand the chance of such events occurring in our climate of today? Could they be even more severe? And could we anticipate that such events could occur? And it was to tackle these kinds of questions that the Unseen method was developed. So better information on extremes, including unprecedented events, can feed into better preparedness and resilience. Now, the idea at the core of Unseen is that what we have experienced, so the observed record, is one of a number of possibilities that could have occurred, but didn't by chance. And because of chaos, we could have seen different climate outcomes. The observations are just one version. But we do have these large initialized ensembles from our climate prediction systems, seasonal and decadal, which are used to bias correct and assess the skill of forecasts. But they also capture different ways in which the atmosphere could evolve. So what we've done with Unseen is to use these ensemble simulations opportunistically as large event sets to probe different possible outcomes. If we wish to use them in this way, model performance must be good enough for our variable and region of interest. It needs to be statistically indistinguishable from observations, and we test for this. It's an important point. We can't use Unseen for all of the applications that we'd like, but where the model does perform well, what we have then is a large event set of pseudo observations, and that's what this figure in the centre is illustrating. There are many more grey data points from the ensemble set against the black data points of the observations. It better samples extremes, including those outside our experience, so gives more robust information on their likelihood in today's climate. And it does this in a physically plausible and consistent way, which also allows us to look into the dynamics of extremes. Now, we've applied Unseen in a range of contexts, and here I've just picked out a few of the UK-focused examples. The first one at the top is rainfall and flooding or drought. The original application of Unseen was to heavy winter rainfall in the UK, and it formed an underpinning component of the government commissioned National Flood Resilience Review of 2016, Unseen was used to provide plausible extreme rainfall scenarios for flood modelling by the Environment Agency to test resilience of existing infrastructure. There's been further collaborative work in this area with the EA again, this time for heavy summer rainfall, and also with CEH for both flooding and drought in different catchments in the UK. So the second example, winter wind drought in the North Sea, or episodes of low winds that would substantially reduce wind power. Wind is already a large component of the energy mix and it's growing rapidly. And as that happens, variability in winds potentially becomes more of a challenge to energy security. So it becomes really important for assessing the requirements for alternative supply and storage to have a good understanding of that variability of the winds and the nature of low wind episodes, say their frequency, severity and duration. And it's that we used Unseen to address. This work also fed into the Royal Society report, which was published last year on large-scale storage. The third example is high summer temperatures in the UK, and this is current work, and I think probably in the interest of time, I'm not going to say too much about this, other than to say that we think it could potentially have applications in the health and healthcare sector. So I'll just sum up by saying that we've found Unseen to be quite a powerful way to probe possibilities of what could occur in today's climate, give more robust information about the chance of extremes, and that has the potential to support decision making. Thanks.
Thanks, Gillian, and thanks to all of our four speakers for those really nice examples of what could potentially be science triggers. So I don't want to say too much more now, but just to wrap up before we go to some questions and remind you that this call for evidence is your opportunity now to participate in this current stage of the process of looking towards the future of UKCP18. So I'll leave you with these QR codes. So there's the one on the left for the UKCP18 call for evidence, and a reminder also of the opportunity to feedback on the UK NCSP strategy on the right-hand side. So I think with that, we'll go to some questions, and I'll pass over to Kath, who is going to chair those.
Yeah, thanks very much, Carol, and thanks very much to all of the speakers for a really fascinating tour through UKCP18 and the sort of thoughts of what we might be able to do going forward. So I will just try and get through a few questions. I know, yes, thanks for the clapping. I will just get through a few of the questions that have been posed here. We may run over very slightly by about 5 minutes, but obviously we understand if people have to go. Remember, this is the whole seminar will be recorded, so you'll be able to catch up on anything you missed out on. But there's been some nice questions in the Q&A. So can we start perhaps with Nick Pidgeon's questions? Who he's said this is to Jason really, that the addition of the sort of additional science that was required, the decision theory, ethics questions are very welcome, but perhaps we're missing the understanding of the contribution of human behavioural response under climate risk and its contribution to community resilience. Have we given some thought to this yet, that it needs really to go just beyond comms?
Yeah, so I can pick up on that one. So thanks for the question, Nick. Firstly, just a reminder that at this stage, we're not fully scoping out options. At this stage, what we're doing is thinking about whether we need to drive an update either from the user side or because there's new capability that enables users to do something. Given that, I absolutely agree with you that if we're looking at the process of building resilience and adaptation, then we need to understand more of these aspects, especially around human behavioural response, nudge, etc. So on the slide, I couldn't fit all of the disciplines, so it's kind of illustrative. But I think the behavioural one is one in particular we did think about. And the question in my mind there, and maybe you can help further resolve this, is that we don't want to lump every single thing into a UKCI project. There's lots of other projects that are really important to the process of adaptation. And in my mind at the moment, it's unclear on the balance of behavioural science that, for instance, sits in informing UKCI versus going into programmes like the UKRI maximising adaptation to climate change. So I agree it needs to sit somewhere, but I'd welcome thoughts on where it best sits.
Thanks, Jason. I will move on to a couple of questions around timescales that people have posted. Sorry, yeah. So I think there were questions from Stephen Wade and Lisa Horrocks mentioning the sort of time frame for the next delivery. So perhaps seeing UKCP next as more of an operational type product than something that was delivered every sort of 6 to 10 years. And then a question from Lisa suggesting that maybe the time is right to leapfrog one of the CMIP 6, and move straight into CMIP 7. Carol or Jason want to take that?
Can I have a first go and then hand to Carol on that, just because I want to be really clear on where we are in the process. So I think it's really relevant to consider different models of delivery, and if we do trigger the idea of an update, we need to assemble some options. I think some of those options need to focus on this idea of more continuous, iterative additions of information, just as Steve is suggesting there. I think others also need to consider the idea of more of a big bang update. And there are pros and cons of each. On the iterative approach, we get the tools, the data sets out as soon as they're ready, but we potentially introduce inconsistencies. The big bang approach, which is what we've kind of done in the past, helps with the consistency, but possibly we could be getting information to users much sooner. On the CMIP 6, CMIP 7 question, to some extent you might say that's tied up with which of those approaches goes forward if we do produce an update. I'd take a slightly different view. I think we shouldn't be throwing away good, useful information that's relevant for decision making. So we should, if we can incorporate CMIP 7, do so, but we should also look to see what's appropriate from CMIP 6 and use that as well. And this idea of thinking when does a particular data set become perishable should be part of our thinking.
Okay, thanks, Jason. There's a question from Daniela on adaptation pathways to climate change that will need information on impacts, losses, damages at a wide range of temperatures. How does UKCP address this? And well, I guess, will it do so in the future? Anybody want to take that?
I could probably say something about that. I think perhaps there is where the new data that we're looking to release in the autumn on global warming levels, I think will help with that. So we're providing an increasing amount of our UKCP products on quite a wide range of global warming levels. So hopefully that will help to offer some of the flexibility in that space. And I think looking forward, I think Fi mentioned on his slide that one of the kind of pieces of feedback we get really often from our UKCP user base is around the need for a wider range of different global warming levels to work with. So those they can help us to underpin the kind of those kinds of pathways. But also a wider range of emission scenarios. So that's something that's very much on our minds as we look further into the future.
Thanks, Carol. Question just come in from Katia on how does UKCP take into account uncertainty added by not considering the Greenland ice sheet melting on weather climate extremes and on as well as on sort of biogeochemical processes in the ocean. I guess will that be something we address in the future going forward? Anybody? We didn't really hear that much about marine, I guess.
Sigurlín, would you like to take that, or shall I take that?
So But I mean, I can comment on the regional part, and on the regional part, the feedback of the biogeochemistry on the atmosphere would be through, and the ocean would be through changes in the ocean color. So this is something that we're thinking to take into account in REP at a later stage, yes. But I'll let you comment on the other global aspects, Jason.
And James, if you want to come in as well, you're welcome to do so. So firstly, let's think where we might include this and what aspects of the cryosphere might we include. So within the global model, we of course do include changes in sea ice, and the global model is capable of capturing some of the teleconnections that we see in reality. I think a really big part of what we do in any upgrade is putting more emphasis on understanding how good the model is at actually representing these relationships that we see in the real world. When it comes to Greenland and the ice sheet, so where could that come in? So one area it could come in is through sea level rise, and we're developing approaches to update the current High++ set of scenarios, working really closely with the Environment Agency. Work that Matt Palmer and Jenny Weeks have been leading, I think, will help us with that aspect. There's also a potential link here via the Atlantic circulation, and that's something that in one sense we would want to pick up in any work we do around hill scenarios, perhaps building on Laura Jackson's work with hosing experiments. But we also need to think about how, for instance, the Atlantic overturning strength does change in the coupled experiments. So in my mind, there is some representation and understanding of these effects, but there's a lot more that probably could be included within the experiment set, and there is absolutely a need here to test whether the model is behaving in the same way as the real world.
Great, thanks, guys. I think we'll come to a close now, but I just want to mention one last comment in the Q&A from Kit Marie Rackley, who's commented that the Met Office are a partner in the Climate Ambassadors Scheme, and just raising awareness of this scheme, and that there's a lot of expertise represented in this room already here today, and that they would really like to get that expertise to support the education settings and sort of work around climate risk and resilience and adaptation. So hopefully people have taken note of that. Thanks very much to everybody. There are a number of other questions, and we will attempt to look across all the questions and come up with some additional responses to our sort of frequently asked questions section as well. So I think it's time to wrap up and just say thank you very much indeed to everybody. It's been great to have our first UK NCSP webinar, and Mike and I will be looking to develop further webinars coming relatively frequently, we hope, and we'll be in touch with all of you about those. Again, see the QR codes here and the link to the call for evidence, and indeed the feedback form for your inputs onto the NCSP strategic framework. The webinar video will be available, and the link to the call for evidence on the NCSP webpage. So thanks again, and we look forward to talking to you about these topics in the coming months.